Hi, geometry students. Hope you can hear me. I'm just putting up some videos that go along with Chapter 10 assignments and PowerPoints. So right now I'm on slide 1 of the PowerPoint. I'll put it up here. Hopefully you had a chance to complete Exploration 1 on page 278. This is what it looks like. And it asks you to, if I look at 278, to look at the figure and to try to come up with some definitions of what those words would be. So if I'm looking at the first one, if I look at a chord, it looks like a segment. It looks like it's a segment that has two endpoints on the circle and that the segment is inside the circle. If I look at secant, secant looks like a line. First of all, it's a line that passes through the circle and it also has two endpoints on the circle, 2 points that intersect the circle. A tangent looks like it is perpendicular to a diameter. Looks like it touches the circle in one point. The radius, most of you know what a radius is. It has a point at the center of the circle and then an endpoint somewhere else on the circle. A diameter is a segment that has two endpoints on the circle and passes through the center. So a diameter is a chord, and it's a special kind of chord that passes through the center. So let's look at. Then you should have used your journal to copy down the definitions on page 280. So I'm not going to go through those. I'm going to go ahead and go to the next slide. And we're going to go through some of the extra practice on page 282. So the first one we have, let's see if I can get to my pen here. On number 2, we are asked to look at this figure and identify two radii. So remember again, a radius has a point at the center and another point somewhere on the circle. So an example of a radius I could call this segment right here is a radius. So is AF and so is AB. So if I'm going to write those, I have to make sure to use the right notation. So I would call it AD and I put the segment symbol over it. Or we could have AB. And again, I have to use the segment symbol. Or I could have said AF. Oops, AF. All right, on number 2, we're asked to name a chord. And remember, again, a chord is a segment with two endpoints on the circle. So some options for chord. I could have, let's see if I can get this to write down here. There we go. I could have EC is certainly a chord. I could have DF, because remember again, a diameter is a chord. It just happens to be a special kind of chord. Or I could have also said ED, right? So ED looks like a line, but if I use the segment symbol, then it says I'm just talking about this part of the chord right here, just this part of the line, which is a chord. In this picture, we only have one diameter, and that would be DF. All right. A secant, remember a secant has to be a line. So it looks like the only one I see here in this picture would be line ED. And again, a secant has to be a line. So I'm going to put a line symbol over to the top. And remember, a line symbol has to have arrows on both ends. All right, next we have a tangent. A tangent is a line that intersects a circle in one point. So it looks like this line here, which they don't really give us a good name for. We really need some other point on there. So I'm just going to make one. I'm going to call it, what letter haven't we used yet? Let's call it, let's make it a G or something. Oh, nice. So I could call it line BG. I don't know why we've stopped writing here. There we go. It's supposed to be a B. It's because I'm off the page. There we go. All right. Otherwise, they would have to have like some little letter M or something, so I can throw an M in there. You could call it, the tangent line could be M also. Right, and then the point of tangency is the point right where that line intersects the circle. So this right here is our point of tangency. So point B would be the point of tangency. All right, let's look at the next slide. This time, we're asked to talk about common tangents. So we have some different kinds of tangents. Common tangents are tangents that are tangents to more than one circle at a time. And then there's internal tangents and external tangents. And it has to do with whether or not the tangents intersect a segment that would join the two centers of the circle. So on this first one, on number 7 here, see if I can get my pen up there. I want to draw some common tangents. So let's see, I could draw one that intersects up here. So I'm going to go right along this line. Ooh, that's a pretty line. There we go. Put my arrows on the end. So that's intersecting here and here. So that could be a common tangent. That's one. Let's see where else I could draw one. I could have one down at the bottom end. So I could have a tangent that goes along and intersects the circles down at the bottom. Come on, pen. Nope. Ooh-wee. There we go. Okay, so intersecting here and here. Sorry about the scribbles. So it looks like I have 2 external tangents that I could draw. Oh, and how do I know they're external? If I connect the centers of these 2 circles, those tangents don't intersect that segment. Come on, pen. So yes, it looks like there's just 2 external tangents. All right, so tell whether the common tangents identified in 7 are internal or external. All right, so first let's answer question 7. So 7 said, how many are there? So I get on number 7 that there are 2, and they are external. If those tangents had crossed the center line, they would have been internal. All right, let's look at the next slide. Maybe. Okay, on number 9, this time it's using the fact that it's asking it to find BD. So if I look, it looks like line BD is a tangent line. And in order to verify, or if this truly is a tangent line, and let's look, I'm gonna look at the directions on 9. Again, it does say that D is a point of tangency. So if a line is tangent to a curve, then it's perpendicular to the radius. So one of the things I'm trying to show is that this is in fact a right angle, or use the fact that it has to be a right angle. So a tangent is perpendicular to a circle at its radius or at its diameter. So if that's a right triangle, then I can use the Pythagorean theorem to figure out that missing side. So that's what I'm going to do. So I need to do 5.5 squared. Let's try that again. 5.5 squared plus, and I'm going to call this piece here, this segment DB, I'm going to call that x. So 5.5 squared plus x squared would have to equal 10 squared. So the Pythagorean theorem should work if this is a right triangle. So I'm going to grab my calculator and I'm going to do 5.5 squared. So that's 30.25. Plus x squared equals 100. I'm going to subtract 30.25 from both sides. And I get that x squared is equal to 100 minus 30.25. And I get 69.75. And so then x is the square root of that. So the square root of 69.75 would be about, and I'll change these to little approximate, about 8.35. Okay, let's look at the next slide. All right, so this time we're moving on to section 10.2. This time it talks about central angles and arcs. So I'm moving on to section 10.2. So central angle is an angle whose vertex is at the center. So if I look here in this picture, let's get my pen back so you can see that. So angle A, whatever this point is, A something B, this is a central angle. It has a vertex on the circle. And then any other angle that has a vertex right here would also be a central angle. Minor arcs are arcs that have a measure less than 180. Major arc is an arc that's greater than 180. If we have an angle or an arc that's equal to 180, that's a semicircle, all right? And its endpoints would be on the circle's diameter. A measure of a minor arc is exactly the same as the measure of its central angle. So major arcs are the difference between 360 and its associated minor arc. So let's look at some of those. Adjacent arcs are two arcs of the same circle that intersect exactly one point. Two circles are congruent if they have the same radius, and one circle can be mapped onto another. Congruent arcs, two arcs with the same measure that lie in the same circle, are congruent circles. And similar arcs are two arcs with the same measure. Hopefully you wrote all those down already in your journal. If you look on page 286 in your journal, you should see all these different theorems that we're going to have. Arc addition just says you can add two arc measures together. Congruent circles theorem says two circles are congruent if and only if they have the same radius. Congruent central angles theorem says if the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. Similar circles, it just says all circles are similar, and that makes sense, right? They all look the same. We know what a circle looks like. All right, so let's look at some extra practice on page 287. This time the directions say to identify the given arc as a major arc, a minor arc, or semicircle, then find the missing measure of the arc. And one of the things you have to notice in the picture is that segment AC is perpendicular to segment BE. Okay, and I can put the little segment symbols in there, which we should have. So let me do that. Go back to blue. Okay, so this AC should be perpendicular to BE. All right, so it's asking us when you see this symbol, that's talking about an arc. So it's asking us for the measure of minor arc here, and I can look, I see it's less than 180. So it's asking me for the measure of minor arc AB. Well, in order to know that, I need to know the measure of this angle. So I'm going to use the fact that AC is perpendicular to BE. So that tells me that this angle in here has to be 90 degrees. I'm going to put a little 90 in there. All right, so that's 90. So I know that arc AB then, if that central angle is 90, then arc AB also has to be 90 degrees. All right, ABC, when you see three letters, that's talking about a major arc, or it could be talking about a semicircle. So if I look at ABC, if I look at that figure, ABC, go pen. See if I can get over there. So ABC is talking about this part of the circle right here. It starts at A, goes through B, ends at C. We know that AC here is a diameter, so ABC has to be a semicircle. So the measure of arc ABC has to be 180 degrees. Next, I have arc ABD. So I start at A, go through B, end up at D. Well, we already know from arc ABC is 180. To go all the way to D, I'm going another 40 degrees. So ABD must be 180 plus 40, which would make arc ABD equal to 220 degrees. Then last we have arc BC. Arc BC is this piece right here. Okay, again, if this central angle is 90 and I know AC is a diameter, then this arc over here also must be 90. Excuse me, this central angle must be 90, and that makes arc BC also equal to 90. The next question says in circle E, oh, and by the way, this is the notation for naming a circle. They have this little circle symbol with one letter, and the letter is always this center point. So in circle E above, tell whether arc ABC, right, this major arc here, ABC, or this semicircle, is that congruent to arc ADC? And our answer would be yes, because they both equal 180 degrees. All right, let's go ahead and look at the next page. This time it says in circle K, find the measure of arc DE. And sorry, my video thing here is in the way. Let's see if I can move it. There we go. All right, look at, we're trying to find, go back. Find the measure of arc DE, this arc right here. All right, so if we look, CE is a diameter, all right? And so what else do I know? Let's look. These two angles here both look like vertical angles. So let's make sure we mark that in, all right? So if this angle is 55, this angle up here also must be 55. Those are certainly vertical angles. They're straight across. We know CE is a diameter. So arc DE then would have to be 180. Whoa. 180, let's try that again. 180 minus 55. Get rid of this, goodbye. Don't pay any attention to that. All right, 180 minus 55. Some of you probably already have the answer. Should be 125. So the measure of arc DE is 125 degrees. All right, question number 11, find the value of X, then find the measure of arc AB. So if I look, I have here, if I look at this figure down below, I know this is 5X, 40, 70, 75 plus 2X, and all of these arc measures to complete an entire circle, I would have to have 360 degrees. So I can set this up as 5X, start over here, 5X plus, and then I've got 40 plus 70, that's 110, plus, then down at the bottom I have 75 plus 2X, and altogether, all of these arcs must add up to 360 because there's 360 degrees in a complete circle. So let's see if I got it right. I got 5X, 70 plus 40, that's 110, plus 75 plus 2X equals 360. All right, so then I'm going to add these together. So add like terms, 5X plus 2X is 7X. 110 plus 75 would be 185 equals 360. Subtract 185 from both sides. Come on. So then I get 7X is equal to 360 minus 185. And I get 175 divide both sides by 7. And I can find the value of X is 175 divided by 7, 25. Okay, so we've answered the first part. It says find the value of X, then find the measure of arc AB. So arc AB over here, see if I can get my pen to go over there. Arc AB, this arc, all right, it says is 5X. So arc AB, oh, I go back. Oh, so I'm going to write back here. I don't know. I lost all my writing. So let's see. Hey. Sorry about this. So we had X was equal to 25. Arc AB, the measure of arc AB, is going to be equal to 5 times 25. So it should be equal to 125 degrees. All right, let's look at the next slide. Oh, it's our assignment. Now this is the assignment for people who do not have internet access. If you have internet access, this assignment is in Schoology. So thanks for joining me today. Hopefully this helped you, and just email me if you have any questions. Thanks.